So like in this problem, the different devices, let me explain the problem. If you guys have any approach, then you can just tell me. So the question is like if you have a positive, we are given an integer d and we are asked to find the smallest integer a such that a has at least 4 divisors and the difference between any 2 divisors of a is at least d. So we have to find the smallest positive integer a. Like if you have to like find its divisors, the difference between them should be at least d, and the number of divisors should be at least 4. So like is the question clear? And any approaches for this question? Okay, anyone? Otherwise, we can just start with the solution part. Okay. So let me just share my screen and then I can explain the problem. Okay. There is no greater than n equals to 6 will have at least 6 devices that take 4. Yeah. Yeah, so it will have at least 4 devices. The minimum should be 2. Sorry, the minimum should be 4. So let's see how we can approach this problem. So is my screen visible? The OneNote screen. You guys can write a +1 in chat. Okay. See. So now like if suppose we have a number, let's suppose x, and we need to divide we need x to have at least 4 divisors, because if we have to find at least 4, so we can make exactly 4. If we want to make greater than 4, so if we just make exactly 4, that would also work. And we have to find the smallest number that have exactly 4 numbers. So let's suppose x has 2 prime factors, p and q, and p and q are different. So what are the possible divisors of x? So first of all, the first divisor is 1, because 1 is divisor of every number. Second divisor is p, the third divisor is q, and the fourth divisor is pq. Will there be any other divisor of x other than these 4? You can write like in chat. Okay. So this is one way of dividing x. Like if x is a form of p into q, where p and q are prime numbers, so these 4 will be the divisors of x. And but this was the case when we had 2 different prime numbers. But if like we had only 1 prime number, so if we just have 1 prime number, the other case would be we can divide in x something like p, and the other other divisor of x should be like p square. So this is done in order to get a difference of at least d. Like in the problem, there is also one constraint that the difference should be at least d. So this is how we can divide the x into 2 parts. So this is the first case, that the number can be of this type, and this is the second case, that the number can be of this type. Is this part clear?
Could you explain the second part?
Oh yeah. See, the first case was for when like the 2 prime number, like there were 2 distinct prime numbers. But in this case, we only have 1 prime number and the other one is its square. So the x looks like something like p raised to power k. So if I'm saying that if this is the case, then I can say the 4 divisors would be like, the first would be 1, the second would be p, the third would be p square, and the last one would be p cube. Like, is this part clear? Like, any doubts in this one? Okay. So now there is one more constraint that we have to satisfy, that is the difference should be at least d. So let's suppose if we just go with the first one, then the condition that p minus 1 is greater than equals to d, the q minus p is greater than equals to d, and again the pq would be something like pq minus q should be greater than equals to d. This is the condition that we have to follow. So in order to construct a smallest number that satisfy these properties, so I can say that the first number would be 1 for sure, because 1 is the first divisor. I will say I'll find the next prime number that is greater than or equals to 1 plus d. So this thing I'm doing because it will ensure that the difference between these two numbers is at least d. So I'll find the next smallest prime number that is greater than 1 plus d. And again, between p and q, I will also find, like, suppose I get a number y in this place, then I will say that the next number should be like greater than equals to y plus d. And the third number like would be pq. So it would anyways be pq minus q would be greater than equals to d. So the first approach is this one, like I can find my number using this approach. The second option that we have is like if the number is of the form p raised to the power 3. So again, I will say that the first number would be 1. The second number would be a prime number, the smallest prime number that is greater than 1 plus d. And again, now the third, like let's suppose it be y, then the third number would be pi square only. And like the difference between them would be greater than equals to d only. And the next thing that we are saying that 4 divisor would be y cube. So like we will calculate both the things, and whatever will be like minimum of these two will be our answer, because we have these two choices to create our answer, and whatever is the smallest of these two will be our answer. So the answer would be minimum of pq comma pq. Like, is this part clear? You guys can write a +1 in chat if this is clear. Okay. Any doubts in this one? Anyone? Okay. I guess if there are no doubts, like we can move to the coding part. Yeah. So the way we can implement this problem is we'll take the input x, and we'll take the two inputs like a and b. So a and b are the two divisors of x, and the way we are that creating the output is like 1 a b and ab that we discussed in the first case. So I will say I'll find the first value a, which is the smallest prime that is greater than x plus 1. The first number is 1, and we have to find the smallest prime that is greater than equals to 1 plus x. So for every I, we are checking whether I is prime or not. So this is like the standard technique for finding whether a number is prime or not, in which we run a loop from 2 to the square root of I, and we check if I modulus j double equals to 0. And at last, we just count the number of factors. If the number of factors are 0, then we say that it is a prime number and we can break out of the loop. So after using this, we get the first number a. Now to get the second number b, I will say that the second number b must be greater than a plus x. Sorry, this x was the distance that we need, to have between the two divisors. So we can run a for loop that starts from a plus x. This is because for the second and the third divisor, we need the difference to be at least x. And we are doing the same thing, that we are finding whether the number I is a prime number or not. And as soon as we find a prime number, we are just breaking out of the loop. Then we see that we have two choices, whether we take a into b or we take a into b. So these are the two choices that we have, and we can just print that thing. Like, is this part clear? Okay. Like, I guess this is clear. Okay, so let's move to the next question. So the next question is k factorization. And in this problem, we are given a positive integer n. We have to find the k integers greater than 1 and their product is equals to n. So in this problem, like we are given an integer n, and let's take this example. This is n. We have to divide it into two parts such that the product is equals to n. So like if we divide this number into two parts, that is 2 and 50,000. So the product of both of them is equals to this number. And similarly, like if we need to divide it into 5 parts, so we'll divide this number into 5 parts such that the product of these numbers is equals to 1024. So yeah. So any approaches for this one? Anyone? What you would like to discuss? Okay. So should I just explain the problem? Like you guys can write a +1 in chat. Okay. Yeah. So the approach for this problem is like, let me just open the whiteboard, then I can explain. So suppose we have a number like, let's suppose the number is x, and we need to divide it into, let's suppose k parts. So like, suppose the problem was like, I want to divide it into 2 parts. So we could have done it like, we would have taken the first number as 1 and the second number is x. Sorry, there was a constraint, I guess. Strictly greater than 1. Okay. So we can't take it like this. Yeah. So the thing is like, suppose x has some factors and they look like we have 2, 2, 2, 3, and 7, 7, 11. And we want to find, and we want to divide it into k parts. So these are the factors, and we, let's suppose k is equals to 4 here. So what I can do is I can just find the first 4, like the first 3 factors. I can arrange them like 2, 2, 2, and the fourth number would be the product of all these things. So that is 3 into 7 into 7 into 11. So 3 into 7 into 7 into 11. Suppose we wanted to create, let's suppose the value of k is equals to 5. Then I will individually pick the 5 elements from this array. So it would be equals to 2, 2, 2, and 3 and 7. So 2, 2, 2, 3, and 7. And the left number would be 7 into 11. And in this way, I can just arrange these elements. So suppose there's one catch here, like if suppose k is greater than, what is its count? It's 7. So if k is greater than 7, then there is no possible way of dividing this element into 7 parts, like more than 7 parts, because the max that we can do is 7. Like we can divide these elements individually because as these numbers are prime, so it can't be divided further. So that is why if suppose k is greater than the number of factors, we can say that, okay, I guess there was a disconnection. Okay. So can you guys tell me where did you lost, where did I lost the connection? Like till which part we have done? Okay.
Sir, this part only, sir. The condition K checking.
Okay. I'll explain that part again once. So yeah, if suppose k is greater than the number of factors, then we can say we can't arrange the numbers into the different parts. Like the maximum that we can do is the number of factors, and that is 2, 2, 2, 3, 7, 7, and 11. If we want to do 1, we can just write all the multiplication of these numbers. And the way to create this create the sequences, let's suppose we start at some smaller number, let's suppose I is equals to 2, and suppose we want to create for k is equals to 5 elements. So what we will do is we will check until, like we will try to create the first number. Let's suppose it comes to, we have another factor 2, so we'll take it. And now we have another number, let's suppose it comes out to be 2 again. And the next factor comes out to be 3 again. So at this point of time, we know that we have created k minus 1 factors. And as soon as we have created k minus 1 factors, we will say whatever is left would come into just one element. So this is the way that we can create the arrangement. Yes, we are finding the factors of the given number that is given in the problem. Yeah. So like, is the approach clear that what we are trying to do? You guys can write a +1 in chat, or if you have any doubts, you can just post in the chat or maybe unmute. Anything works. If the size of factors is less than k, yeah, then it is -1 because there is no possible sequence. Okay, great. So I'm assuming that this part is clear for everyone, and let's get into the code part. Okay. So initially what I'm doing is this is our count. That is like we are taking the inputs n and k. That is we have to divide this number n into k parts. And there is the count that I'm using to store how many factors have I found until now. And I'm starting at the smallest, like I'm starting at the prime number 2, and I'm finding what all the prime factors of this number are. So I'm running a while loop until n is not equals to 1. So that is the, like if n double equals to 1, we cannot divide it further. So we have to end our loop at that point anyways. Now the condition is like, I'll tell you why this flag is being used. So I'll say that if n modulus I double equals to 0, which means I is a factor of n, then I will say that while n modulus I double equals to 0, that is until this number is the factor, what I'm doing is I'm checking if count double equals to k minus 1, because if count becomes anytime equals to k minus 1, I can break out of the loop. And this flag is equals to 2 means that we have found the count is double equals to k minus 1. Otherwise, if count is not equals to k minus 1, I'm creating there is a vector also that is storing the result, and I'm pushing into this vector the element I. So I is the factor, and I'm dividing n by I. So in order to reduce the number, I'm just dividing n by I, and I'm incrementing the count. So this process will go again and again until I is the factor. And if we get a point where I is not like I is not a factor anymore, we'll just go to the next part and we'll check if flag is there. Like if the count is double equals to k minus 1, then we can just break out of the loop. Otherwise, what we'll do is we'll increment the I. So we'll find the next factor of the element. Again, like we'll repeat this process again and again. And if we get to a point where count double equals to k minus 1, we will break out of the loop. Now, the next thing that we are checking is if count double equals to k, the count double equals to k minus 1 and n is greater than 1. So if like n is greater than 1, then I can say that I can just print the vector z, and I can just print the n that is left. So I have printed the k minus 1 numbers in this loop, and whatever the number that was left, I have printed it down there in this statement. And after that, I can return. Otherwise, I will say that if both of these conditions don't satisfy, that is, if count is not equals to k minus 1, or if like if count is not equals to k minus 1, then we can just say we can just print a minus 1. So like, is this part clear? By the way, in this, the flag was used in order to break out of the loop, because this break would just break out of this while loop. And in order to break out of this while loop, we are just using a flag. So if anytime the flag is true, we are just breaking out of the loop. Okay, Angit. Great. Like, is it clear to everyone else also? You guys can write a +1 in chat. Like, or if there is any doubt, you can just uh, write it in the chat or maybe unmute. Okay. I guess there is no doubt. Let's move to the next question. So the next question is Nirvana. And in this problem, let me explain the problem statement. So, okay. Okay, so we are given a number n, and we have to find what is the maximum possible product of digits in the range 1 to n. So let's suppose there's an example, we take an example, like the number is 390. So we have to check what is the maximum product of digits of the numbers from 1 to 390. Let's suppose basically the number is 389. So the product of 389 is 3 into 8 into 9, that is 216. The product of 3 into 9 into 0 is 0. So we have to find the maximum product of digits among the integers 1 to n. So that is a problem statement. Yeah. Like, is the problem statement clear? Okay. So yeah. So let me just share my screen and I can explain which we how we can approach it. So see, like suppose we have a number and it is, let's take the example only, that is 390. So we have 390. So what do you guys think? Like, what would be our numbers in this? What would should be the digits in order to maximize the product? Like among 1 to 9, if we have a 9, the chances of the product reaching the maximum increases. So what we would try to do is we would try to increase the number of nines in that in this number. So like for example, 299 has more number of nines than this one, so it will give a better answer for this one. So we have to find that how can we create this, like what would be, like we will try to maximize the number of nines one by one in order to get the maximum. But there is one more problem, like if I just try to create a number like 299, it is not the biggest number. So what is the biggest number? The biggest number is 389. The reason for that is because 9 into 2 is basically less than 8 into 3. That is why taking 389 is more preferable. But like it contradicts our statement that we initially made, that the number of nines are reducing. But like we have to increase the number of nines. So the thing is that we'll try to increase the number of nines one by one, starting from the rightmost position, and we'll calculate the product of every number that we are able to create. Let's suppose the number be like 2478. So what I will do in this one, I'll try to create a 9. Okay, can you do this by converting the number into string if the number is less than 10? Like if the number is less than okay, like if the number is less than 10, then the number will be maximum between 1 and number. Now what does this mean? Like okay, like in this else case, you're saying that we'll convert the number to string and fetch the digits. And like how will we try to find the maximum?
Hello.
Yes.
Yeah. So if in any chance, if we have a number that is less than 9, for example, 1 to 9.
Okay.
So the maximum number will be the 9, isn't it?
Yeah. Yeah.
Yeah. And if the number is greater than 9, then we will have the number into 2 or 3 digits, like whatever it is, up to 10 raised to the power 9 or 18. So we can just convert the number, and we convert the number into the string, and we will fetch the digit by digit by using a common base. That is my approach.
Okay.
And then
Like suppose like if the number is 2478, like how we're trying to calculate the answer?
I mean, I will just able to fetch the digit by digit, for example, the last digit by using some common base. That is my approach because I have solved this type of question in CodeChef contest, and
Okay.
it was like the question was asked around the base of 20.
Okay. Like
Yeah, so
calculating it to a base, what, like how is that working? Like
I mean, I'm not able to come up with a proper thing, but I'm just sharing you like a half through code,
okay.
like a base of 10, base of 100, like whatever it is.
Mm-hmm.
But just this was my approach because it is a very big integer. I mean, you will see the time constraint and the integer length. It was around 2 into 10 raised to the power 9.
Exactly.
So in the
Exactly.
worst case scenario, the 10 raised to the power of 9 multiply 10 raised to the power 9 and multiply by 2 into 2, whatever it was, it will just, there will be an overflow of the integer and long also.
So yeah. Like but the thing is
Yeah.
no, that we have to find the product of digits. So even if the number is like 10 raised to the power 9, so maximum it would go something like this. This getting repeated 9 times, so the length of it would be 9. So the maximum number that we have to calculate is 9 raised to the power 9 only, something like that.
Yeah.
So like it won't overflow actually, but you're right. Like for computing, you can't obviously run a loop because the time complexity won't work. We have to go digit by digit. That is right. Like this approach is right. In like we have to make some observation that how can we increase the maximum answer. Like if the number of nines are more, then it would be surely better for us. Like in this case, if I try to create a 9 at this position, I can make this a 6 because the range is from 1 to n. So sorry, I can't directly make it 9 So what I will do is I'll decrement this number also. So the number that we would be able to create is 2469. So this is one possible candidate for the maximum answer. The next possible candidate is we'll try to create two nines at the end. So creating two nines would look like this, and here is a 3. These are the, like, this is the third candidate for the answer. And similarly, we'll try to create now three nines at the end. So it would go like this. But now here we can't take a 2, so we have to take a 1. So these are the three possible, like these are the four possible cases that would give us the maximum value. We have to create the number of nines starting from the right. So we'll try to create 1 9, then 2 9, then 3 nines. And we have to maximize our answer in this way. Like,
Okay.
did you guys get this approach? Like, Ankit and everyone?
Yeah, I get it.
So, like, there is one more reason we cannot directly take this number. Like, even though there is 999, the number of nines occurring is 3 times, but we cannot directly take because of this issue that we just discussed. Like, 299, like 289 is better than 299. So even though it has more number of nines, sorry, 389, but this gives the bigger product. So that is why we cannot directly take all the nines. We have to check for these cases also. So this is like the number of nines are increasing one by one. Now let's look at the code that how can we implement it, because I guess the meeting is I'm taking it on my personal ID, so it might end in like a few minutes. So I want to complete the code, and if there is any doubt, I can create another meet also. So yeah, in this problem, what I'm doing is I'm just taking the input n, and I'm currently doing a n plus plus. The reason I will tell you down that why I'm doing this. And this is a function to calculate the product of digits. So this is a lambda function in C++. And this is like I'm using, this function is used to calculate the product of all digits. Now, while n is not equals to 0, what I'm doing is I'm calculating my answer. So initially, what I'm doing is like, let me just explain how I'm trying to find the answer. Let's suppose the number is 2, 4, 7, and 8. So it is like 2, 4, 7, and 8. I'm increasing n by 1, that becomes 2, 4, 7, 9. And what I'm saying is I'm just multiplying this number into 1 and I'm subtracting 1. So it becomes 2, 4, 7, 8. The next thing that I'm doing is I'm just dividing this number by 10. So it would become 2, 4, 7. But now this time I'm multiplying it by 10 and I'm subtracting again 1. So it would become 2, 4, 6, 9. The next time I'm again dividing it by 10, and what I'm doing is I'm multiplying it by 100 now. So it become 24 into 100 minus 1. That gives me what? 2399. Now again, the next time what will happen is we'll divide by 10 again, and it will become 2 into 1000 minus 1. It becomes 1999. So in this way, I've calculated the 4 possible ways that we just discussed the above also. And I'm for every number, I'm just calculating the product of digits and I'm maximizing. So like, did you guys get this part, that how are we trying to make the numbers? Like the approach of creating the numbers one by one. Okay. Yeah. Like any doubts in this part, that how we are trying to calculate it? Okay. Let me show into the code that what we are doing there. Yeah. So in this one, like we are taking n and we are doing the n plus plus because of the reason that we just discussed. Like we are multiplying it initially by 1 and subtracting 1. So it would give us the original number only. So this is the p that we're multiplying the number with, and the answer is initially 0. So we have to maximize the answer. This function is used to calculate the product of digits. So this is the standard way of calculating the digits. We extract the digits one by one and we just multiply it. So yeah, we can calculate digits like the product by this function. And we are running a while loop while n is not equals to 0. So as in the one note that we saw, the number was getting divided by 10 again and again. So there will be a point when n will be equals to 0. At that point, we can just break out of this while loop. So the answer would be maximum of answer comma product like product is the function. We're calling it for n into p minus 1. So initially n into p minus 1 would give us the original number. After that, what I'm doing is I'm dividing n by 10 and I'm multiplying p by 10. So after that, like if this while loop runs again, then this product function n into p minus 1 would give us the number that has two nines at the end, and the number is in the range 1 to n. And this while loop will run again and again, and this answer variable will get maximized, and we can just print the answer at the end. So yeah, is the approach clear? Like if there is any doubt, you guys can just write in the chat. Maybe a +1 just if you have any doubts. Okay, like if there are any doubts in the above three problems that we discussed, you guys can tell me, because I guess the meeting is going to end in 2 minutes. Otherwise, like if there are any doubts, I'll create a new meet. Yeah. Okay. Like, is it clear to everyone? Like, if it is clear, then you can write a +1 in chat now. Okay. Great. So I guess this part is clear. Then we can end the session. And thank you for joining and have a good day.